So in this video I plan to show 3 different spiral patterns in Cornlathe: spiral index, spiral line, and spiral rosette. And I'll be using a 2-inch diameter poplar cylinder that's about 2.5 inches tall. So for this project I could use a variety of different cutters, from ball cutters to ball nose to cove bits to fly cutters. In this project I'll use a fly cutter similar to this one. This one has a polished carbide insert, and that's the one I use since doing this video, and an ordinary fly cutter with a 1/8 inch carbide cutter on it. I drive them with an 800 watt DC motor. However, there are some clearance problems. When I wind this motor ahead with an ordinary fly cutter, right away I hit the motor. So that limits me to about 2 inches with this particular fly cutter bit. So in order to avoid those problems, I created a fly cutter with the bit offset about 15 degrees, and that way I can move the motor back and at an angle, and the fly cutter will still encounter the wood at 90 degrees, and that gives me a lot more clearance between the workpiece and my motor. As you can see, when I move it forward, there's a lot more clearance in there. I'll adjust that clamp point later. The first example will be spiral index, and I could use the existing 2-inch diameter cylinder I already have created there, as I know the dimensions. But I could do that by just deleting all the cut points and dimensions, but I think it's better to create a new one. So if I go up to the folder and right click, I've already pulled that out. I'll call this spiral index. And it came up with the original that I had. So I'll clear those off, clear everything, create a new cylinder, same as before. Go up to outline, let's call it 2 points vertical. I'll check my outline. I got lucky, they're both at 1 inch and this is at 2.5 inches, so I got very lucky. I don't have any cut points there yet. This is front inside, I don't want that, I want front outside. And on my view, I want the outside view. The thickness is a little thin here, this is 0.1 inch, so I'll change that to 0.25, a 1/4 inch. My cutter I typically use 0.6, and I want spiral index, so I will drag that with my left mouse button over to the axis here, put it there, and I'll drag that down there. Now that cutter is in a horizontal orientation, and I don't want it like that. So I have to change these down here to the cutter frame, universal cutter frame. I want this rotation. If you change this one first, it saves an extra step. Call that 90, and I'll call this angle 90. If I left click on this, that changes it to what I want. This is cutting about a 2-inch strip. I don't have the lines turned on, so we can see, well, look at that, it's doing a line like that. The default is 8, so let's look at the cut points here. It's a 90-degree line, index curve 8. So that means 8 repeats, and I want about 16. That'll look more interesting. This, if you look here, it shows 0.05 to 0.05. You can actually taper this cut. say if this was 0.01 inch at the top, and then becoming more shallow towards the bottom. That's how you do that. Let's render this and see what kind of a cut I get. And that's about what I want. I think I want it slightly deeper. Right now my depth is this. See, here's end cut depth, 0.05. Well, perhaps I'll just leave that there for now, so I don't have to fiddle with anything. But this is the start depth right here. Cut depth. If I wanted that, say 0.01 or 0.1 rather, that would be that. It recalculates it, but that'll look a little odd until I go change the end cut depth to 0.1 as well. And what that'll do is make these just a little bit sharper there. If I turn off the lines and spin it around, we can see how that's going to look. To change the angle, right now this is set at 90 degrees, same as before, and I could change that twist to 60, for example. It'll recalculate that, and that gives a little more upright. I could change that to 120, and that would look kind of weird, but not unattractive. But I will go with 90. This comes out as uniform diameter. You could choose one of the other ones if you wanted, but I leave it at there. That's the default. So that's all I need for this one. Go up to the G code, same as before, crank these right up. I leave these alone. I'll go with this rather than always positive or always negative. I go always negative if I've got my chuck screwed on, but most of the time I hold my wood lathe chuck in the metal lathe chuck. Write my G code, and as it shows down here, it's being written. I go back to the favorites window. It's already been written. I haven't converted this. Normally I would convert C values to A in Notepad++. So we'll go to the shop. Here is a plain 2-inch poplar dowel. This is actually a terrible wood to use for this project, but it has a uniform dimension and it's very fast for me to chop off a piece. That first straight cut was because I forgot to hook up my C-axis, but I decided to cut over it anyway. Now Cornlathe programs the grooves to be cut in one go. So you have to be quite careful about the depth that you choose. In this example of 0.1 inch, it works fine in poplar and it'll cut as well as it can do, but it does deliver the pattern in a fairly crisp package. For this one I'm using a 1/8 inch carbide fly cutter with a 60-degree tip on it, and as I mentioned at the beginning, it has about a 15-degree angle to the axis of rotation, so I can set the motor off to one side. This gives a pretty nice cut, but I found that the polished carbide insert type cutter that I showed at the beginning of this video gives a beautiful cut across the bottom of these. Those types of inserts are meant for cutting aluminum or brass. The edges are very, very sharp, much sharper than any steel inserts, and it does a beautiful job on wood. And the nice thing is about those, when they get dull, you just unscrew them, flip them around, and you got a brand new cutting edge. But it takes a long time for carbide to get dull in wood. The speed that this is cutting is because of how I set the speed and RPM controls when I created the G code for this. I find this is sort of a reasonable pace to go for the power of motor that I'm using and the type of cutter. And of course this poplar is very soft. The motor is rotating at about 800 or 8,000 RPM, and that's more than adequate for this project. Cornlathe doesn't give you any additional retraction from the surface of the wood. So sometimes on your projects you'll find the cutter just barely touches the top of the wood on the backstroke or the return stroke to the beginning. And that's very frustrating when you've got a nice project planned on a nice piece of wood. I found that if I enter my cutting diameter at 0.6 inches, for example, but I actually measure and set the diameter at 0.55, that extra tiny bit of clearance of 0.05 or less inches is enough clearance that I don't get cuts on the return stroke. As you can see, this is cutting rather quickly. If you were doing a 2-inch box, you'd be done in no time. I ordinarily hold my wood lathe chuck in the jaws of the metal lathe, because that way I can go in positive and negative directions and don't have to worry about unscrewing anything. I have mounted the wood lathe chuck on a threaded piece held in the metal lathe jaws, but I've since quit doing that. Now all of these cuts, as you see, the peaks of each groove are very sharp. There are some fuzzies, but they come off with very light sanding or a plastic brush or a plastic rotary brush in the drill. You have to be very careful with sanding that you don't take the sharpness of those peaks away, or it doesn't look very good. So all the cuts work out except for the very last one, and that's cutting the beginning of the very first cut, and you can get chip out using a fly cutter like this. So as mentioned, a cove bit or a ball nose bit might be better for this kind of cut. So that's already done. You can see the offset of that fly cutter, although I try to have it square to the workpiece. But this works out very well.
In this example, I'm going to create a spiral line pattern. We're back at our favorite screen in our test folder. I'll create a new template I'll go through the usual way, Cornlathe template. And the name will be Spiral Line. And that's good. It's populated as in other examples, so I'll get rid of all of that. And I'll build my own simple cylinder, 2 inches in diameter and about 2.5 inches high. I'll make those 2 points vertical. Come down to my outline, and I'm pretty good with that. I could change the 2.547 to 2.5. That gives me a pretty exact measurement as before. So I can go on to my cut point setup. I'd like my thickness to be 0.25 as with the other examples. Don't bother with the curve resolution, that's fine where it is. I know I want to be front outside, so let's get up to our view. Changing that, change my thickness back. I want my cutter to be 0.6. And I know I want a universal cutting frame, and these ones should be at 90 degrees. I leave this as the ideal cutter because it renders faster. So here's my piece set up, and I can drag a spiral line on there just as with the other ones onto the axis, drag that endpoint down, and turn the lines on. And the default gives you a twist of 90 degrees, so I'll put that to 0. We'll go back to this. I don't want to taper any of these. I want about 18 of these. So you see the same as what I filmed. This is sine, that's good. The amplitude I want is 0.3, and the period I want is about 1.5. So that gives me a sort of a gentle curve there. And this uniform I want to be sine. But I won't put any twist or amplitude on that. So if I render that now, this renders pretty quickly because it's a straightforward thing. I'll turn the lines off and you can see the kind of a pattern I have there. So as usual, I will go up here, create the G code. I won't change any of this. I'll write it, and it will show up in my favorites right about now. Here's my spiral line G code. So as I do, I'll take that into Notepad++, change all the CXS values to A, and save it. And with that, I can go on to the workshop and show you how that one cuts. So here we are with the same 2-inch poplar dowel and that same offset fly cutter running at about 8,000 RPM. And the speed is similar to the first example. But these spiral line cuts are an attractive way of doing fluting on something. If you watch carefully on the return stroke, it'll just touch the tops of some of those fuzzies. Sorry for the camera shake. And as mentioned in the last example, sometimes you have to fool the program by actually having a shorter cutter than what you program in by just enough that it doesn't touch. The peaks once again are very sharp, but in this poplar there's lots of fuzzies, and then it doesn't cut cleanly with this one at the very bottom. One could argue that a rounded insert would do a better job, and it does, but I've got a 60-degree point on this one. And that polished carbide insert I mentioned in the last example, that does a beautiful job across the bottom of these. Just slices it off very cleanly. So this is actual speed. This is going to get this done quite quickly.
There's not another program out there in the world that I'm aware of that can do it, this kind of pattern, as easily as you can with Cornlathe, with the bonus that Cornlathe is free. That's a pretty hard combination to beat. Nobody else can do it, and Cornlathe is free. How much you get in the way of fuzzies, of course, depends on the orientation to the grain of the wood, and you can see it gets a big pile of fuzzies always in the same cutting direction across the grain. I have some rotary brushes I can use in a drill that are actually from the jewelry industry, and they're stiff bristles. They're not plastic, they're a pig bristle or something of slightly different thicknesses, and they do a very nice job on the fuzzies for this, much better than sandpaper. And I certainly don't want to have to be sanding down in the bottom of those grooves. It's nice to keep this pattern just as crisp as you can possibly get it, and it looks the best that way. But keep in mind, depending on the kind of wood, the depth of cut that you specify. In this case it was 0.05 inches, as I recall. So for a 2-inch box, this pattern is a little bit bold. It does look okay. And it cuts very quickly, that's for sure. What you see is what you get. When this is done, it's done. Having the preview feature in Cornlathe, if you had a wider box or a curved box, that certainly gives you a much better idea of what your end product is going to be. Sometimes if the lines are too far apart, then the tops of the grooves are not that sharp, so they're not that appealing. But already here's the last cut. And that's done.
The last pattern I'll demonstrate is spiral rosette, the last one here. And as before, I'll go to test folder, right click, make a new one. Through all templates, remember, go to other and corn template. And I'll call this one, I'm going to leave that all one word for now. Call it spiral rosette. I don't want any of this, so I go to outline and clear everything. As before, I can make a 2-inch diameter cylinder, 2.5 inches tall. I'll make sure those are vertical. Come down to my outline, and I got lucky. They're all more or less what I need. I could change that one to 2.5, and then it's the same as the other examples. So in this case, I can see that this orientation is wrong, so I go front outside. I'll make the wall thickness 0.25 once again, and I'll make my cutter 0.6. Now I know from experience that the horizontal cutter frame and the horizontal orientation of the cutter are correct for doing this particular pattern. So I left click, drag it to here, and then hold on that button or that cut point and drag down the end cut down to there. Then I can go over and start altering the cut points. So I open everything up. I know that I want my depth to be 0.1. Depth is very important on this particular pattern. I want my end depth to be 0.1. You can taper these, as I've mentioned. And the pattern I want is not sine. I want Tudor rows, believe it or not. And I don't want 8 repeats, I only want 5. If we go to the view window and turn on lines, you can see they're twisted, and I don't want to twist. So I go to that, change twist to 0, so they're vertical. And then I can render this. This will take a little longer to render. As I mentioned, depth is quite important in this one to get what you think you're getting. If it's too shallow, like 0.05 of an inch, you won't get much of a pattern. But if it's deep like this one, you can see the whole thing is a Tudor rose, the outside of a Tudor rose. I'll turn the lines off. And that looks quite pretty. So if this was on the top of a box, it would do a Tudor rose around the top as a rose cut. But now you extend it all the way down the bottom, and that looks quite nice. Once again, I go to the G-code window, go to the cut rosette. I don't change a whole lot of this. The problem with this one is it starts cutting very quickly, but then it's only moving to the left at 0.2025 inches at a time. It's a very shallow movement, so it takes forever to cut it from top to bottom, or bottom to top, depending on what you want to do. So that is ready to go to the shop and show you what that one looks like as well. So here we are with the same type of 2-inch poplar dowel. You'll notice right away that the cutter is in a horizontal position. The other two examples, it was in a vertical position. Cornlathe automatically builds in this circumference reduction. I don't see any setting for it, and I don't know how to stop it from doing that. But that's fine, it doesn't seem to affect anything. So this will do a few cuts per Z position. And this first series of cuts are very quick. When it gets further to the left in the Z-axis, each move is only about 0.02 inches, so it's really slow. So this kind of pattern takes forever to cut, so it seems. However, I guess the benefit of that is you get a very, very clean cut. You don't have to do any finishing towards the end. The grain, of course, is oriented top to bottom on this piece of dowel, so it cuts very cleanly. You don't get fuzzies on the top of anything. This cutter, once again, is a 60-degree carbide 1/8 inch diameter insert, and it seems to be the best one for this kind of cut because it's very sharp. Here's the finished cut going back. The speed of rotation is because of how I slid both those things to the right when I was setting up the G-code. But as I said, after it finishes this, it doesn't move very far to the left at all. If I ever figure out a way of speeding that up, then I'll put up a video about that, but so far I just don't see any way. This rotation back to A0, and then moving in a little bit, and then rotating again back to A0 is some kind of default built into Cornlathe, and there doesn't seem to be any way of changing that. This is how Bill wanted it to be cutting. So it's actually moved over a tiny bit to the left. You can't see it, but it did do it. This first cut you don't notice much of anything, but when it does its second lap around, you can start seeing just on the very left edge a tiny bit of progress. You have to be super patient with this particular spiral cut. It seems to be very depth sensitive too. To get a nice design, I found I have to be at least 0.1 inch in depth. Anything shallower than you don't see the pattern that I'm trying to cut here. There you can see it's just tickling the edge of the left side of those grooves. So I'll cut away to an end view here so you can see what that looks like. And you can see how the pattern is cutting the entire outside of the box. It's going to look very cool when it's done. But as I said, it takes forever. To do, say, this 2-inch length would probably take about 3 hours or something like that. And it's not running the motor particularly hard. It's only going about half speed, about 8,000 RPM. And the cutter's not working hard, so it's just that it takes so long. There won't be any finish needed when this is done. It will produce that clean a cut with the orientation of the cutter and the orientation of the grain. I can't think of any other program that would do a cut like this nicely. So that brings us to the end of this video. I hope you've learned something from it. And you can also look at the examples in the example files that are included with Cornlathe, and they will give you an idea of other ways of using this as well. Thank you for watching.